This is a brief introduction to the statistical concept of random block experiments. Before I give an example, I want to review the general flowchart and logic behind this method. This experiment begins with the experimenter selecting a specific subject to research. After the selection is made, the subject is divided into subgroups, of which these are called blocks. Then these blocks are randomly assigned some sort of treatment condition. This method is applied due to its ability to easily manipulate nuance factors. Nuance factors are non-important variables that can affect the result but are not of interest to the experimenter. Typically, there is one variable of interest, which comes with multiple nuance factors. These nuance factors are manipulated when the subsets or blocks are created. Through this process of blocking, the nuance factors can be reduced, eliminated, and ultimately be controlled. Ideally, homogeneous blocks are wanted with consistent nuance factors and varying values of interest. For instance, a nuance factor for the laser experimenter would be the stray light from the surrounding environment. This will affect the results of the experiment, yet are not of interest to the experimenter. The stray light effect can be reduced or eliminated as a nuance factor so that the results only depend on one variable, which is the humidity. Here we will proceed to the example, which will make the statistical jargon make much more sense. Here, the subject of the experiment is lasers. These lasers are split into two subgroups or blocks, which in this example's case are two different companies, Coherent and Lasers R Us. These blocks will be tested in conditions of 0% humidity and 20% humidity. To make this more tangible, a chart can be produced outlining the overall experiment. On the left, the blocks are defined, two laser companies. On the top right, the treatments are defined of either 0 or 20% humidity. Under these treatments, corresponding to the laser company, there are 15 lasers in each block, for each company being tested with each treatment. Once completed, the quality of the incidence light between the two companies at both 0 and 20% humidity can be compared. Ideally, when comparing the values between the two laser companies, the results are accurate due to both the randomization and sensitive control of limiting the unwanted nuance factors. Overall, the key to this method being useful is the ability to control the unwanted nuance factors from altering the result of the experiment. Nuance factors will invariably exist, so it is highly important that there is a method with the ability to control their unwanted effects.